Hello guys, and welcome to this new tutorial. In this video, we are going to talk about machine learning project, or more precisely classification project, which is hard failure prediction. In this project, we are going to learn how to import data from CSV file, how to do data cleaning, how to do exploratory data analysis, data visualization, and finally we will have data modeling. So first we have to import the libraries that we are going to use in this project. First we will import Pandas as PD. So Pandas is used for data frames and for data manipulation. Since we are going to import a CSV file and we will have it as data frame, thus we are going to use Pandas to manipulate or to work with this data frame. Then we'll import NumPy as NP. So NumPy stands for numerical Python. And for example, if you want to convert a list to an array or something like that, we're going to use NumPy. Then we have two libraries that are used for data visualization. We have import matplotlib.pyplot, so we have the pyplot layer as PLT, and we will have import Seaborn as SNS. Okay, so these two packages or libraries can be used at the same time to create data visualizations. After that, we have to import the train test split. So we write from scikit-learn.model selection import train test split. And the train test split is mainly used to split our dataset into training data and testing data. After that, same thing from the scikit-learn package.preprocessing, we import standard scalar. As we will see in this project, all the data from the different columns that they don't have the same range. Thus, we are going to use the standard scalar to normalize our continuous variables. Thus, it will help us to increase the performance and the accuracy of the results of our models. After that, we are going to import the classification models or algorithms that we are going to use in this project. So from the same package, from scikit-learn.linear model, we import logistic regression, as we will have binary classification, so we will have 0 or 1. Thus, we are going to use logistic regression, and it is classified as the first or the top algorithm that is the most used in kaggle competitions. Then we have the scikit-learn.svm, we import SVC, so the support vector machines algorithms. We have the k-neighbors classifier. So from scikit-learn.neighbors, we import the algorithm. Then same thing we have from scikit-learn.tree, we import decision tree classifier. We have the naive Bayes algorithm. So we write Gaussian NB. And finally, we have the random forest classifier. So we write scikit-learn.ensemble, we import random forest classifier. Here we have the accuracy score. Since we have a classification project and we will have results using this classification algorithms, we are going to import the accuracy score metric. So we write from scikit-learn.metrics import accuracy score. So this is about the different libraries and packages that we are going to use in this project. So we run that. Okay, so like that, we have imported all the libraries, the algorithms, and the metrics that we are going to use in this project. Now we'll have the first part, which is importing and exploring the dataset. If you want to create this title, you can click on New Cell. So here we have the cell is designed to write code. You can convert it to Markdown. And you can add hashtags. For example, you can add 2 hashtags and you write part 1. If you run that, you get the following title. Same thing, if you have only 1 hashtag, you can have the following title. The more hashtags you have, the smaller will be your title. Okay? So this is about creating this title. We are going to cut this cell. Then we are going to import our data. The link to download the CSV file is available in the description, and you can put the file in the same folder where you have your Jupyter notebook. so that you can directly import the CSV file by writing the title of the file .csv. Okay, so to import that, we write pd.readcsv and we write the title of our file .csv, and we name our data frame as data. So if we run that, and if we want to know the type of our variable, which is data, we write type data. We run that, we can see that it is a data frame. Okay, after that we can write data.shape, okay, to know the dimension of our data frame. Same thing, if we run that, we'll get 299 rows and 13 columns. So same thing in here, we have the notes or the comments that we can add from the different cells. Okay, so same thing here, we have 4 hashtags. We write note, then we add our comment. So we have written, we have 299 lines or rows and 13 columns. Okay, same thing, if we want to know the different columns that we have, we can write data, which is the name of our data frame, dot columns, and it will give us the 13 columns that we have in our data frame. So we have the age, the anemia, creatinine, phosphokinase, diabetes, ejection fraction, etc. And as you can see here, the last column is what we want to predict. So we have the death event, which can be 0 or 1. This is why we call it binary classification. So we'll have two cases. We'll have either death event equals to 1 or death event equals to 0. Same thing, we are going to use the data.head. Okay, so it will give us by default, as you can see here, the 5 first rows or the top 5 rows in our data frame with the names of the columns and the different values. So we write data.head, and for example, you can change it here to 10. It will give you the first 10 rows, and you can change it to 100, etc. Okay, so here we have the age. As you can see here, it is continuous. We have here anemia, it can be 0 or 1. We have creatinine, phosphokinase, it is also a continuous variable. Diabetes, it is categorical variable, etc. So the last column, which is death event, it is either 0 or 1. Here in the first 10 rows, it is 1. Okay, so this is about the head function. It will help us to have the first view or an idea about the different types of variables that we have, the names of the columns, etc. Then we have splitting our dataset into 2 categories to make it easier for analysis. Okay, as we have said later on, for example, for the standard scaler, it will be applied only for continuous variables. And to make it easier and to understand better our dataset, we are going to have 2 different categories. So we have the categories variables, which are anemia, diabetes, high blood pressure, sex, and smoking. And the remaining are the continuous variables, like the age, the time, and ejection fraction. And as you can see here, we'll have it in the double square brackets. We are going to create the data frames. Okay, so if we add new cell in here and we write type of, for example, categorical variables, it will give us the following result, which is going to be a data frame. Okay, this is why we have used the double square brackets. Okay, and same thing in here, we add our columns using the markdown. Okay, so we convert the cell to markdown, we add the hashtags for the title, then we add our different comments. Here for the anemia, for example, 0 means that the person does not have anemia. If 1, it does. Same thing for diabetes, same thing for high blood pressure, smoking, and sex. And as you can see here, in the categorical variables, we don't have the death event since it is our predicted variable. Okay, so we don't add it in here in our categorical variables. All right. Then we have some functions that we use to see if we have non-values or null values in our dataset. So generally, Kaggle datasets that don't have any missing values or any null values. Okay, but I have added this function so that you can use them, for example, in other datasets that you can download, for example, from different websites rather than Kaggle. Okay, so these functions are really useful to give us the different null and not a number values in our data set. For example, we have here our data. If we write only data, it will give us the following. As you can see here, we don't have all the rows. Okay, so we have here the 3 dots, which means that we have rows between this top 5 and the last 5 rows. If you want to display all the rows, we can use this function, which is pd.setOption. So display max rows, and since we have 299, we can write 300, which means that it will give us all the rows in our dataset. So here by default, don't have all the rows, but if we add this option and we run that, we'll have all the rows. Okay, so we'll have all the rows from 0 to 298. Okay, as you can see here, we have all the rows. Okay, now same thing here, we have table, which means that we write data.isNA. It will give us a true or false. As you can see, we will have false, false, false for all the rows in all the columns, which means that all the values are numbers and we don't have any NaNs, right? As you can see here in this note, you can see that there is no missing data in our dataset. And the sum, it will give us the sum in each column, right? So age we have 0, anemia we have 0, until death event we have 0, which means that we don't have any NaNs in our data set. Same thing, we can use that for the null values, and if you can see here, we run that, we have false. Okay, false, false, false. When we add the sum function, it will give us the sum in each column, and as we can deduce here, we don't have any null values in our data set. Then we have function which is describe function. Okay, so it is used within Pandas library, and the describe function, it helps us with the descriptive statistics. As you can see here, for example, we have the minimum age is 40, the maximum is 95, so it will give us the different calculations like the count, the mean or the average, the standard deviation, the minimum, the maximum, and for example the median, etc. And this describe function, it can be only applied to continuous variables. For example, if you have categorical variables and apply describe function, you cannot find the mean for categorical variables. This is why we have split our data set into continuous variables and categorical variables, so that we are going to use the different functions easily and to understand better our data set. So if we execute that, we have continuous variables.describe. It will give us the different results for our continuous variables. So here we have, for example, for the age, we have the count is 299. Since we have 299 rows, then we have the mean, which is the average. Okay, so we have the average for each variable. We have the standard deviation. The minimum, as we have said, for the age is 40. The maximum is 95. Then we have the quartile, so 25%, 50%, 75%. And this is for all the continuous variables in our data set. Same thing, we are going to use another function, which is group by. So here we are going to see the total rows that have death event equals to 0 and the others that are equal to 1. For example, here we have for death event equals to 0, we have 203, and for death event equals to 1, we have 96. We can deduce that our dataset is unbalanced. So here we have our result, which is presented in a table, but we can do the same thing using data visualization. For example, to do that, we can create two different data frames. We can create the age. Okay, as you can see here, we have age, which is equals to data double square brackets h, and plotlet, which is data double square brackets plotlets, right? If we run that, we get the following. If we use only one square brackets like that, for example, for the age, and we run that, we get what we call series. So the type of the following variable is going to be a series, right? As you can see here, we have pandas.core.series.series. But when we add our square bracket, we get the following. We get a data frame. Okay, so we do the same thing for the second variable. We are going to use the two data frames in order to plot or to get a scatter plot. Here we have the title, visualizing the unbalanced data with a scatter plot, and the colors will depend on the death event. Since we have binary classification, so the death event, it can be 0 or 1. So we are going to use that variable inside our data visualization to distinguish between the zeros and the ones in our scatter plot. So to do that, we are going first to create figure. So write plt.figure, and here it is the fixed size. Okay, for example, we can change it to 15, and you get another dimension. We can change it to, for example, 20, and you get the dimension. Okay, so we're here for creating the figure with a fig size. Then we write directly plt.scatterplot. So we write plt.scatter. So here we have the plotlets, right? Then we have the age. So this is the x-axis, then the y-axis, right? And C stands for the color. Here we can use directly the series. Okay, so the data death event directly with only one square bracket, and we put it in C, which stands for the color, right? Then we have the size. Okay, for example, it can be 10, it will be smaller. It can be 50. As you can see here, it will increase by increasing the size. Okay, 100, you can put it, for example, 500. Okay, so it will increase by increasing the size. Then we have alpha. So alpha, the greater is alpha, the darker is the color. For example, here if I put 2, okay, but if I will put 0.2, it will give us this following. Okay, so alpha is for the darkness of the color. Okay, so we put it 0.8. Then we have plt.xlabel. So we put here whatever we want. Okay, so we have plotlets. For example, if we add s like that, it will be as follows. Okay, so you can change the title as you want. Same thing for the y label, which is the age. Okay, so plt.y label, same thing here. If I add e, it will change the title or the label of the axis, right? And same thing for the font size. So for example, you can put it 10, it will decrease. If you put it 100, it will be bigger. Okay, so this is for the size of your label in your axis. Okay, we put it to 20. Same thing for here. Okay, for example, if you put it 200, it will be very big, right? As you can see here, it is very big. So it is about the size of your label. Okay, and for the title, it is the same thing. So visualizing the unbalanced data. Okay, so you can put anything that you want in here. Since it is a string, okay, so it will be a string for all the titles. And same thing for the size. If we add 0 in here, it will be very big, right? So add it as 20 or 22. Then at the end, we add plt.show. If we don't add that, it will be displayed, but we'll have the following text which will be displayed, right? So we add plt.show at the end of the figure, right? So here we can see the unbalanced data in the form of a scatter plot, and as you can see we have a lot of values which are in purple. So as we can deduce here, we can see that we do have more circles in purple than in yellow, which means that all the zeros are in purple and all the ones are in yellow. So this is for visualizing the unbalanced data using scatter plot. The next step is finding the relationship between the different variables and also the variables and the death event. To do that, we are going to use a heat map from the Seaborn library. So first, we are going to create a figure, right? As you can see here, we can use Matplotlib and Seaborn at the same time. First, we can create the figure by writing plt.figure, fixed size equals to, you can give it any size that you want. Then you write sns.heatmap. Here, the data.correlation or data.core, it will give us the following. If we print it or display it in here, we have the following table. So we have age and age, it has a 1, which means that they are correlated, and all the values are between -1 and 1. Okay, so if it is closer to 1, it means that they are correlated. If it is closer to 0, it means they are not correlated. If it is close to -1, it means that they are negatively correlated. Okay, so here we have the following result, and we are going to display this result using a heat map. So to do that, we write sns.heatmap. We write the following. We write the result in the first part. Then, as we have said, it will be between -1 and 1. So -1, it means that they are negatively correlated. 1, they are positively correlated. And if it is 0, it means that the two variables, they are not correlated. Then here we have the color. Okay, so it means that we have chosen this following colors, okay, from -1 until 1, and you can choose any map that you want. And for the annotation, we have chosen to be true. If we put it to false, okay, so we'll have only the colors and we will not have anything displayed in the different cells. Okay, we are going to put it to true. Okay, and here we add our title. Same thing, so we write plt.title and we write relationship between all the variables of the dataset and death event. Same thing, we choose font size equals to 22 and we have added plt.show here. So we are going to cut that, and what we can deduce is that you can notice that there is a positive correlation between death event and serum creatinine, okay, which is death event in here and serum creatinine, all right, which is 0.29, as you can see here. So they are correlated. And also with age, okay, so we have age here and we have death event, it is 0.25, okay. Same thing, we have also negative correlation between death event and time. So we have here -0.53, right? And also we have ejection fraction in here, which is -0.27, and serum sodium a little bit, right? So we have here serum sodium, which is -0.2, okay? So we have here a relationship between all the variables and the death event, okay? And heat map is useful since it gives us the possibility to display this relationship using the colors and also the annotation. This is also very helpful to have an idea of which variables that you can choose in order to train your algorithms and models to get better results. Okay, so this is about the heat map. Now we will start the second part, which is data visualization. In this part, we are going to see the impact of each variable on the death event, which is our predicted value. So first, we are going to create two lists. The first one is for categorical data, and the second one is for continuous data. Then we are going to start with categorical data, and we are going to plot the impact of these variables on death event. To do that, we are going to create new figure. So we write plt.figure, fixed size equals 2, so you give it the size that you want, and we are going to use for loop. The for loop will help us to avoid writing the same syntax 5 times. Okay, since we have here 5 different variables, which are anemia, diabetes, high blood pressure, sex, and smoking, we are going to use a for loop using the enumerate function, and we are going to plot these graphs in 5 different plots using this for loop. So we are going to write for I and categorical data. You can write here any variables that you want. In enumerate categorical data, which is our list, we are going to create subplots. Okay, so plt.subplot 2 and 3, it will create for us matrix which has 2 rows and 3 columns. And in each of the subplots, we are going to add a graph in it. Okay, once we defined our subplot, we are going to create a count plot in this subplot by writing sns.countplot. The data equals to data, which is our data set, x equals to cat, and hue equals to death event. So the hue, it means that we are going to use death event as a legend or as the different colors. Okay, as you can see here in this graph, we have for 1 it will be in orange, and for 0 it will give us a blue. Okay, and we write plt.show. Once we run that, we get the following graph. Okay, so when I equals to 0, it means that we have here 2, 3, 0, which is here the first plot. It will give us this variable, which is anemia. So here we will have anemia, and on the x-axis we will have 0 or 1. Then we will have the count. So for death event equals to 0, we have this value, which is approximately 120. And for anemia equals to 1, the death event equals to 0, it is about 80 or 85. Okay, for anemia equals to 0 and death event equals to 1, we have approximately 50. And for death event equals to 1 and anemia equals to 1, we have approximately 45. Okay, same thing in the second graph. When I equals to 1, we will have diabetes, and it will give us the subplot, which is 2, 3, 2. Okay, so 2, 3, 2, it is the second graph. Okay, then we have here the third graph, the fourth graph, and the last graph. To understand that better, we have the following. So we are going to create these subplots one by one. Okay, and for example here we'll create figure, right? And we are going to create matrix which has 2 rows and 2 columns. In the first one, we are going to create anemia, and in the fourth one, we are going to create diabetes. Once we run that, we get the following. As you can see here, we have 2 rows and 2 columns. Okay, so 2 rows and 2 columns. And in the first subplot, we have the anemia, which we have put in here. And in the fourth one, we have diabetes. Okay, so this is the first plot, the second plot, the third, and the fourth. Since we didn't define the subplot in 2, 2, 2 and 2, 2, 3, so we don't have anything. We have only for anemia and diabetes. So this is just an example to explain to you why we have used a for loop, okay? And the reason is to avoid writing this syntax 5 times. And for the for loop, it will give us the following. Using the enumerate function, for I, cat, in enumerate categorical data, we'll have the following. So once we execute that, we'll have 0, it is for anemia in here. Once I equals to 0, we have subplot 2, 3, 1, which means that the first one, and we will have anemia, right? So it will put anemia in here, as we did in here. Then it will give us the first plot. Same thing for the second. When I equals to 1, here we will have 2, and we will have diabetes, and so on until the last one, which is smoking. So here using a for loop and the enumerate function is really useful to avoid writing the same syntax 5 times. And as we have said, for the count plot, it will give us plots which are like bar plots and which will have a legend that is defined in here. So hue, it is death event, and it will give us the colors for each category. For 0, we have two colors, 0 or 1, and same thing for 1, we have two colors which are 0 and 1. Okay, so this is the impact of categorical variables on death event. And what we can deduce is that for death event equals to 1 and when categorical variables are equals to 1, the values or the counts are less than the counts when these categorical variables are equals to 0, except for sex. Okay, so when we have sex equals to 1, we have the death events are greater than the sex equals to 0, which means that the total deaths in males category is greater than total deaths in females category. Okay, now we'll go to the continuous variables, and plotting the impact of continuous variables on death event, we are going to use a histplot, which means that we are going to use a histograms. We are going to create a new figure by writing plt.figure, and you can define any size that you want. We are going to use for loop. Okay, so for j and continuous in enumerate continuous data, which is our list, plt.subplot. Here we have defined 3 rows and 3 columns since we have 7 different variables. Okay, so we have 3 rows and we have 3 columns. Okay, same thing, we write plt.subplot 3, 3 and j plus 1. For example, when j equals to 0, we have here subplot 3, 3, 1, which is age. Then we have creatinine, phosphokinase, then ejection fraction, etc. Right? Same thing, we create sns.histplot, data equals to data, which is our data set, x equals to continuous variable, it starts from age until time, and hue equals to death event. Here we have put multiple equals to stack. For example, if we omit that, we are going to get the following. So we don't have clear plots and the colors are not very clear regarding death event. So we are going to use stacked bars. All right. And same thing as we have said for I cat in enumerate continuous data, which is our list, we get the following. So for 0 we have age. Okay, so here we have 0 subplot 3, 3, 1, which is age, until I equals to 6, which is the 7th subplot, and it will give us the time. Same thing for the histogram, we write sns.histplot, data equals to data, which is our data set. For example, here we have the continuous variables, which are age, creatinine, phosphokinase, ejection fraction, platelets, serum creatinine, serum sodium, and time. Hue is death event, so we have either 0 for blue or death event equals to 1, which is in orange, and we have multiple equals to stack, which means that we will have stacked bars, right? And as you can see here, for example, for age, the death event is higher when the age is in the 60s and in the 70s. For example, we can see that for the creatinine, phosphokinase, approximately all the values are less than 1000, and for the values close to 0 we have a higher death event. Same thing for the ejection fraction. For example, we have the higher value of, or the higher count of death events is approximately at 40. And same thing for platelets, we have all the values of death event equals to 1 are between 200k and 400k. Same thing for serum creatinine, we have the values which are less than 2. Okay, so as you can see here, orange, the values in orange are less than 2. Same thing for serum sodium. For example, we have the higher value is, for example, at the value or 135, okay, for death events. And for the time, we have the higher values are less, for example, than 100. Okay, so between 0 and 25 or 30, we have the higher value of death event. Okay, so as you can see here, for the continuous data we use histograms, and for the categorical variables we use count plots. Now we are going to use another type of graphs, which is box plot. Okay, so box plot mainly will give us the median and the maximum, the minimum, and the quartiles. Okay, so it is very useful when talking about median, about the different quartiles and the interquartile range. Okay, same thing, we are going to create a box plot for two different variables. So we have sex and age, and we are going to see the impact of these two variables on death event. Okay, same thing, we write plt.figure, we create our figure by giving it a fixed size, and we write sns.boxplot data equals to data, which is our data set, x equals to sex, so we have either 0 or 1, and y we have age, which is a continuous variable. As you can see here, it starts from 40 up to 95. Okay, and for the colors it is death event, so hue equals to death event, and we add a title. So plt.title, we have the impact of sex and age on death event, and we have here the font size. Okay, once we execute that, we get the following. As you can see here, for example, for males, okay, for sex equals to 1, approximately the median is for in 65 when death event equals to 1, and approximately 60 when death event equals to 0, whereas for females it is both 60 for death event equals to 1 or death event equals to 0. Okay, so as we have said before, for the age, as you can see here, it is approximately at 60 or 65 that we have a peak, or we have the higher value. Okay, so this is about the box plot. Now I'm going to analyze the survival status on smoking. To do that, we are going to create two new data frames, which are smokers and non-smokers. For the smokers, we are going to select from our data frame, which is data, all the rows where smoking equals to 1. For the non-smokers, we are going to do the same thing. We are going to select all the lines where smoking equals to 0. After that, we are going to use these two new data frames to create other data frames, okay, which are non-survived smokers. So we are going to take the smokers data frame, and we are going to select all the rows where smokers equals to 1, which is the smokers data frame, and death event equals to 1. For the survived non-smokers, we are going to take the non-smokers data frame, and we are going to select all the rows where death event equals to 0. Same thing for non-survived non-smokers. So we are going to take the non-smokers data frame, and we are going to select death event equals to 1. So which means that they did not survive. Finally, we are going to select the survived smokers, which means that we are going to select the smokers data frame, and we are going to select all the rows where death event equals to 0. Once we get the values that we want, we are going to create two new lists, which are smoking data and smoking labels. So smoking data will take the length of all the different data frames that we have selected. So length of non-survived smokers, length of survived non-smokers, length of non-survived non-smokers, and length of survived smokers. In the same order, we are going to create the second list, which contains the labels. So smoking labels list, it will contain non-survived non-smokers, survived non-smokers, non-survived non-smokers, and survived smokers. So for example, if you want to select the type of non-smokers, it will give us the following. Okay, so we'll have type of non-smokers, it will be data frame. Same thing, if you want, for example, to select this one, smokers death event equals to 1, we will get the following. Once we execute that, we get in the smoking column, we will have only ones. Okay, so which means that we have smokers, and death event equals to 1, which means that all the people that did not survive. Okay, once we have our data frame, we are going to calculate the length. Okay, so length of smokers death event equals to 1, it is 30. And when we divide 30 by the total rows, which is 299, we will get 10%. Okay, so we'll get the percentage, and it is this percentage that we will plot in the donut chart. Okay, same thing for the remaining. We have 30 137, 66, and 66. So this is the smoking data list that contains all the values, and here we have the smoking labels. Okay, so these two lists, we are going to use them inside this pie chart, and after that we'll create this donut chart. Okay, to do that we are going to create a new figure. Okay, so plt.figure, and we give it a fixed size 99. Then we are going to create a pie chart. Okay, because we cannot directly create a donut chart in Matplotlib. So first we are going to create a pie chart. The first parameter, it will be smoking data, which is the first list. Then the labels will equal to the smoking labels, which is our second list. Then here auto percent, we will have only one decimal number, and the start angle, it will be 90. So here it will create for us the pie chart. So if we copy and paste that, it will give us this pie chart. Okay, after that we are going to create a circle, okay, which has a center and a radius. Okay, and the color, it will be white, which is this one in the middle. We'll get the current figure, so we write p equals to plt get current figure, and from p, which is our current figure, we get current axis, and we add the circle. So we'll add the white circle into the pie chart. Okay, once we get that, we add our title with the font size, and we write plt.show. Okay, if we decrease, for example, the radius, it will be 0.5. As you can see here, it will be smaller. Okay, if we will increase that 0.8, it will be like that. Okay, so this is about the white circle, okay, that we will put in the middle, which has 0, 0, which will have its center in the middle. Same thing here for auto percent. If we want two decimal numbers, we'll get the following. Okay, 10.03, 22.07, 22.07, 45.82. Okay, so this is how we create a donut chart using Matplotlib. Okay, and as you can see here, for the non-survived smokers, we have 10%, 10.03. Survived non-smokers, which means that the non-smokers that did not survive represent the highest percentage, which is 45.82. Then we have the non-smokers that did not survive represent 22.07%, which is equal to the survived smokers. Okay, so this is to represent the different percentages using a donut chart using Matplotlib, and it gives much more information than the count plots or the bar charts. Okay, so this is another way to represent your data, especially percentages. Okay, and we are going to apply the same process for the remaining categorical data. Okay, for the second one is sex. Okay, so we are going to create male data frame. Okay, so we'll take the data, which is our data frame, where sex equals to 1. Then for female, we take sex equals to 0. So non-survived, it means that death event equals to 1. Survived male, it means that male, where death event equals to 0. Same thing for non-survived female, we take the female data frame and death event equals to 1. And finally, survived female, we take female data frame and death event equals to 0. Same thing, we create our list for the values and our list for the labels, and we create a new figure, right? plt.figure with a fixed size. We create our pie chart, we create the circle. Okay, we get the current figure, we add the white circle, and we add our title with a font size. Okay, same thing in here, we have the highest percentage is for survived male, which is 44.1%. Then we have survived female with 23.7%. After that, we have non-survived male with 20.7%, and finally non-survived female with 11.4%. Okay, same thing for diabetes. We create data frame with diabetes. Okay, so diabetes equals to 1. Without diabetes, we will have diabetes equals to 0, and we are going to use this new data frames to create our non-survived with diabetes. Okay, so we'll have the first one, then survived with diabetes, non-survived without diabetes, and survived without diabetes. Okay, we create our list of values, our list of labels, and same thing, we create our donut chart. Okay, here we have the highest percentage is survived without diabetes. Okay, then after that we'll have survived with diabetes. Okay, 28.4%. Did not survive without diabetes, and finally we have non-survived with diabetes with 13.4%. Okay, after that we have anemia. So without anemia, so with anemia we'll take our data frame with anemia equals to 1, and without anemia we'll take our data frame with anemia equals to 0. Same thing for the non-survived with anemia, survived with anemia, non-survived without anemia, and survived without anemia. We create our list of values, we create our list of labels, then we create our figure. Okay, we have our pie chart, our white circle, and we add it to the chart, right? Here we have the highest percentage is survived without anemia, okay, with 40.1%. Then we have survived with anemia, 27.8%. Then after that we have non-survived without anemia, so 16.7%. And finally we have not survived with anemia with 15.4%. The last one is analyzing the survival status on high blood pressure. Same thing, we take our data frame with high blood pressure equals to 1, and we call it with high blood pressure. And without high blood pressure, we take all the lines where high blood pressure equals to 0. We create our data frames. Okay, we create our list of values, our list of labels, then we create our donut chart. Okay, here the highest percentage is survived without high blood pressure with 45.8%. After that we have survived with high blood pressure with 22.1%. In the third position we have non-survived without high blood pressure with 19.1%. And finally we have non-survived with high blood pressure with 13%. Okay, so this is about analyzing the different percentages using donut charts. Okay, and as you can see, it is very efficient when working with percentages and with different categories, because we'll have the labels, the percentages, and also the colors, which are really clear, which are insightful for our analysis. The third part, which is the last part, is data modeling and prediction using continuous data. So we write x equals to data, double square brackets, and we add all the continuous variables. We have the age, creatinine phosphokinase, ejection fraction, serum creatinine, serum sodium, and time. And our predicted value is death event. So we write y equals to data death event. We are going to use the train test split. So we have x train x test, y train y test, and we write train test split. So we use the train test split function from scikit-learn, and we write x, okay, our continuous data, our features, and y, which is our predicted value. Then we define a range for our testing data. We will have 70% for training data and 30% for testing data. And we write random state equals to 2. After that, we are going to scale our data. We define our scalar by writing standard scalar, okay? Then we define our x train scale, which is defined as following. So we write scalar dot fit and transform x train, okay? So we are going to fit and transform x train, okay, to our new range, and we'll do the same thing for the x test, right? So we write x test scaled equals to scalar transform x test, okay? This is our testing data, so we don't want to fit our testing data, okay? So we fit only our training data, right? So we run that, second one, third one, and here we define a list to save all the values from the different models that we are going to use later on for comparison using bar chart, okay? So this, we call it accuracy list. And we start by logistic regression. So we import our algorithm, we call it LR so linear regression model. We fit our model, so we write lr model.fit xtrain scaled, which is this one, y train, and here we will have our prediction. So lr prediction equals to lr model dot predicts x test scaled, which is this one. After that, we are going to find our accuracy score, okay, and we are going to round that to 4 numbers, right? So that we'll get a percentage with 2 decimal numbers, okay. Finally, we will append our score into our list, okay. So this is for logistic regression, and we do the same thing for the support vector machine. So we define our model, we fit our model on x train scaled y train, we will have our prediction and our accuracy, okay. Same thing, we will have 4 numbers and we get a percentage with 2 decimal numbers. We append that to our list, and like that we will have 2 values, logistic regression and support vector machine. Same thing for the k nearest neighbor, okay. So before that, we are going to write a code in order to find the optimal value of k. To do that, we'll define a list, which is knn list, and we are going to define a range from 1 to 50. So we write a for loop for k in range 1 to 50. We'll have our model. For each time it will get a value of k, so 1, 2, 3, 4 until the last value. Then we fit our model using this value of k on x train scaled and y train. After that, we get our prediction and our accuracy. Each time we'll append it to this temporary list, which is knn list, and we are going to plot that, right? As you can see here, in the first value we'll have accuracy like 75%. Second one, it will be like 84.5. Here we have like 83.5. For the fourth value, we'll have the same thing until here. So when we count the number or the value of k, we'll define, so 1, 2, 3, 4, 5, and 6. Okay, this is why here we have defined k neighbors classifier with k equals to 6, because we found that the highest value is for k equals to 6. Okay, same thing, we are going to fit our model on x train scaled y train, our prediction and our accuracy, which is rounded to 4 numbers, and we get a percentage with 2 decimal numbers. We append our value to our accuracy list. Like that, we will have the 3 first models. So we have logistic regression, support vector machine, and k nearest neighbor. Next algorithm, we have decision tree classifier. Okay, so we define our decision tree classifier with our criterion and max depth equals to 2. We are going to fit our model, so x train scaled y train. We'll have our prediction, our accuracy, and we append our accuracy to our accuracy list. Okay, so this is the 4th algorithm. The 5th algorithm is naive Bayes. So we have Gaussian naive Bayes algorithm. Then we fit the same thing on x train scaled y train. We'll have our prediction and we'll have our accuracy. Same thing, we'll have percentage with 2 decimal number, and we'll append our accuracy into our accuracy list. We have our final algorithm, which is random forest classifier. Same thing, we'll define our model by writing rf model equals to random forest classifier. We fit our model on x train scaled y train, rf prediction, accuracy, and we'll append our accuracy to our list. Once we display our list, we get the following percentages. Okay, after that, we are going to define a new list that contains the names of the algorithms in the same order of the values that are inside the accuracy list. So our first algorithm is logistic regression, and we have SVC, k nearest neighbor, decision tree, naive Bayes, and finally random forest. Okay, so these are our models, and in order to compare the accuracy between all the different algorithms, we are going to use bar chart. Okay, to do that we are going to define figure, so plt.figure fixed size equals to 12.7. Then we are going to define an axis, so we write x equals to sns.barplot x models y accuracy list, and x label, so we add label on the x-axis, label on the y-axis with font size. After that we are going to define a for loop, so we write for p in x.patches, we'll get our width, the height of the bar, and we are going to write x equals to p.getx, y equals to p.getY, and after that we are going to add the annotation. So x we are going to use it with the width, y we are going to use it with the height, and this value are going to be in the center, right? And finally we write plt.show. Once we execute that, we get the following figure. As you can see here, the highest percentage is with decision tree, the second one is with logistic regression, and the least one is with naive Bayes. So that's all for this end-to-end data science project. I hope that you have learned new things. Thanks for watching and see you in the next tutorial.